Hello, hello, hello. Good afternoon, Internet. Welcome. Welcome to day 32 of NL Math Man's Math Help Stream. Welcome to my daily break. This is yeah, this is the part where I get to chill out for 6 minutes or so and just ramble about things. And also show off part of my lunch that I didn't get to eat, I guess. Let me go over to this window. Oh, okay, here we go. See? Look at that. You see what that is? Now I know I mentioned earlier, right, that I didn't actually get to do the barbecuing that I wanted to do the weekend. So I went and I made some Chinese food afterwards. I did this was the pork that I brined. I brined it overnight to get it ready to do on the barbecue. I brined it in vinegar, salt, sugar, pepper, some spices, right? But then I couldn't actually get it on the barbecue because of the weather that we had the weekend, the amount of wind that we had. So I went ahead and I sliced it up nice and thin into strips, and then I velveted it. The velveting is a sort of a Chinese or Oriental, I guess, par cooking technique where you cook the meat partly first. You can either water velvet or oil velvet, or what I do is I follow the great advice of J. Kenji Lopez Alt, who is one of the food writers at the Serious Eats blog, which is an excellent blog for anything cooking related. He recommends water velveting with a bit of oil in it to give you some of the oil flavor without all the ridiculous amount of calories. That's what I did. I did the meat in a water with oil velvet, and then I briefly fried it afterwards to order. To order. Listen to me. It's like I'm back being a prep cook in a kitchen again. No, it wasn't to order. It was to me eating it. Right. And then I did some noodles in my steamer basket, and above noodles in a pot, and then in the steamer basket above that, I did some frozen vegetables, quick. And the sauce is actually the sauce is real nice. I mentioned my sauces before. This sauce was from an episode of the Hairy Bikers that I saw on Netflix, which is a phrase that a British person wouldn't bat an eye at, right? Because it's a known thing. Like Psy, whatever his name is well known. Then you tell it to anybody here, and they're like, what are you into? What sort of? I don't want to know what porno you're watching, buddy." But it was a Hong Kong style sweet and sour sauce with a cup of brown sugar, a cup of ketchup, and a full can of diced pineapple. I also start off with a blonde roux with onions because I like that because that's how I make my sauces, right? I get like a quarter cup or so of butter, sweat that one down with half an onion, let that get nice and soft, and then I chuck in about 2 tablespoons of flour, get all that mixed up, and then oh yeah, I use a cup of stock as well. So I use a cup of stock, uh, full can of pineapple, cup of brown sugar, and a cup of ketchup. So there we go. This is NL Cooking Man stream, which honestly I would have a lot of fun doing that one. Maybe I should see. Maybe for a fun stream some Friday or something. I'll see if I can't get my webcam set up in the kitchen. Walk you through I don't know, something good. Fried chicken. I do a nice double fried chicken actually. I haven't made that in years, but I worked on my recipe quite a bit. Boy, it must have been 10 years ago now since I really worked on that recipe. But I got a good one. A nice fried chicken. Who doesn't like fried chicken, right? That's like one of the fundamental foods. You mean real butter, right? Not that margarine stuff. Exactly. When I say butter, I mean butter, butter. Like, from a cow, directly from a cow. No, I mean actual butter. Yeah, margarine is of course like an emulsified oil and water mixture. So if you're using margarine, you're really kind of just using a bit of oil and a bit of water, right? Which once it warms up and breaks down, it doesn't really fry right. Now, when I use butter, I use actual butter. Sometimes I clarify it first, but yeah, I usually start off just with normal old, like, I don't know, Atlantic Choice or whatever the cheap one is. Yeah. Oh yeah, it's got to be proper butter. I mean, that's what sets the pros apart, right? I mean, look at Julia Child's recipes. They're like the most immortal, like time-tested French cooking recipes, and every single one of them is like half a cup of butter to start. It's glorious. Okay, I would love to sit here and just banter about food a bit more, but I'm going to get into some mathematics, I suppose. Seeing I got to, whatever. right? First up, I'm going to introduce sine law and cosine law. Those are really, really, really good topics. Betty Ann, I know you're starting those now in your next unit, but those do come up again in your program, and they also are the final topic in the general program. So Esther, I know I mentioned to you before that that the last few courses do have a bit more trigonometry. Well, this is it. Sine law and cosine law are the final topics of your entire math program, and they're not particularly difficult, but they are a bit of they do bring together a lot of the algebra rules that we've been going over and sort of combine that along with the trigonometry rules. Um, but yeah, it's kind of just like a combination of Pythagorean theorem and then sine and cosine, right? But a really good topic to cover. Then, Esther, I will continue on with some stuff for you then and get into a brief review of the test that you're doing soon. And then Math 2020 Unit 1, so that's Brittany. That'll be a review of surface area and volume. But again, a super common topic that's in lots and lots of the courses. So if that's a topic that you're working on, then that'll be beneficial to you. Yeah, my stream title is both a Simpsons reference and a and sort of a nerd reference, a mathy reference too, right? 5 bits. Bits in computer lingo is powers of 2. Like, so if something is 8-bit encryption has a 256 characters, or 250, goes from 0 to 255. 5-bit, if there ever was such a thing, would be 32, right? Because 2 to the power of 5 is 32. You don't really hear about 5-bit anything, but I'm no expert on computer architecture. I know powers of 2 though. We got them. So anyway, let me bring up over here now my oh oh, that's unfortunate. I knew I forgot something. Okay, hold on just one quick second. I've got the pages written down that I want to get to. I just need to bring them up into my document viewer program. Let's see, that was page 39, 139. There it is. And then page 150. There it is. Okay. So just one quick second and I'll be good to go here. All right. Switching on over. Document display. Here we are. Okay. So first up, we're going to do some questions on sine law. So sine law looks a lot simpler than cosine law. It's only a little bit simpler, but it's kind of, like I said, it's an evolution sort of the trigonometry that we've seen already. All right, let me just zoom in a tiny bit here. So this is Math 2101A. And Math 3102C, right? It's a topic in both, but I am going to be drawing from the book for 2101A. Right? So, as it says here on the page, let me zoom in a bit more so we can see it a little clearer, because I don't need all that space along the side there, do I? So, the sine law can be used to determine unknown side lengths or angle measures in acute triangles. Right? So, you can use the sine law to solve a problem modeled by an acute triangle when you know 2 sides and the angle opposite a known side, or 2 angles and any side. Well, yeah, I mean, 2 angles. It's impossible to know 2 angles in a triangle. You either know 1 or you know 3. Because as soon as you know 2, you know the third one, right? Because we know that the maximum, that all the angles in a triangle add to 180. So we either know 1 or we know 3. Okay? But sine law, so just to briefly explain how it starts, sine law requires a known side and a known angle opposite the known side. I don't know, it seems like I'm using the word known a whole bunch here. That's really what we're saying, is that if we have any triangle at all, let me break out one of my triangle stencils here. So if we have a triangle like so, right? Like that. If we know say this is an unknown side, and this is an unknown side, and we know this side is 5, right? 5, whatever, 5 meters, say. Okay? And then if we know, as long as we know this angle over here, say this is like, I don't know, 32 degrees, okay? And say this one here is, I don't know, 41 degrees. Now we have enough information to use sine law to solve for this whole triangle. So if we can find any side on this triangle because we have this pair, right? We can find this angle here, of course, right? Because we can subtract from 180. So again, like I said, we never have a situation where we only have 2. We can always find the third. We would find the third here by 180 subtract 32 subtract 41. So 180 subtract 41 is 139. 139 is going to be 107. Right? Yeah, that's right. Okay. But never you mind about the blue ones. Never you mind about the blue. Let's go ahead and solve for these other ones, right? Because as long as we have a pair of angle, or sorry, inside an angle, we know that that's going to be the same as the other ratio between the sides, right? So here, the top ones, these are sides, and the capital ones, these are angles. We know these have to be angles, right? Because we can only take sine and cosine of angles. We can't take sine and cosine of sides. But here, for example, say we know that so this side, 5 meters, corresponds to sine of 32 degrees, which is over here, right? So then we also know now that side y, whatever it is going to be the same sine 41 over here. So this one divided by sine of this is going to be the same as this one divided by sine of this, right? So then if I go through and do it on my calculator over here, right? Before we do any trig, I would recommend always checking to make sure that your calculator is on degree mode, because we use degrees here, not radians. In my calculator, it's in here. In your calculator, it might look as like a DEG RAD sort of symbol at the top. Make sure it's on DEG, or your answers are going to be a bit off, because that's a lot off, because that's a different way of measuring angles. But let me see, sine 32. I'm just going to go through. You don't have to do this. Go through and fill them in as decimals, but I'm going to. Sine of 0.5299. For some, I've always rounded signs, like in school and stuff. They always showed rounding signs to 4 decimal places. I don't know why 4 specifically. I'm just going to keep doing 4 because that's what I was told. 0.6561. Okay. So now I can go ahead and I can do the division over on the other side. 5 over sine 32. 5 over sine 32 is going to be 9.4354 equals y over 0.6561. Now I'm going to multiply across here. So we're going to have this times 0.6561. That's going to get us 6.19, so equals y. Right? And that matches up with what I know about triangles as well. Right? Because I know that here, the side that's 5 meters long is opposite an angle that's 32 degrees. And this is the smallest angle of the 3, so we know that this should be the smallest side. This angle is a bit bigger, so we know that this side should be a bit bigger. And hey, when we go down through, it checks out. So this triangle that I just made up, if this is 5 and this is 32, this is 41, then this has to be about 6.2 meters. That's basically how we use sine law, right? And now it does mention here on the page that it can be more convenient to do it the other way around. That's totally fine, right? You can take the reciprocal of all these, it still works out fine. A over sine A equals B over sine B is how I usually write it to start off. But, I mean, we can just as easily call that sine A over A equals sine B over B. It's totally fine. Right? That works too. Just always, 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 you have to be taking sines of angles. You can't really take sine of a side. It doesn't mean anything, right? So yeah, let's go into a few of the specific questions. I'm going to do page 139, questions three to five. I'm going to pick some of these. Maybe I'm not going to do all of them, but I'm going to do a few out of these ones here. So this is Math 2101A Unit 3, right? And then we have, let's see, 3A. Have a triangle. Now I'm just gonna use my triangle stencil. I know it's not gonna look as nice as those in the book, but like I keep telling you, right? Um, Diagrams don't need to match the angles that are written on there, and in fact, they generally won't. Like intentionally, they won't match. Right? Now, one of the nice things about this page here, um, right? Just to just to remind you that that is down there as well. So yeah, just to okay, I sort of lost my train of thought there. But one of the nice things about these questions is that they tell us beforehand that these ones are going to be solved using sine law, not cosine law. So here we don't need to be determining which one to use, although in plenty of cases you're going to be able to use both. Like here we could go ahead and use cosine law if we were going to, but generally sine law is a bit easier when you have the choice. But what you need to do sine law is a pair of angle and side opposite to it. So here we have this angle, we don't know that side. We have this angle, we don't know that side. We have this side, but we don't know that angle. But of course we can find the angle, right? Just like we did on the previous one, we can do 180 minus 53 and minus 68, right? So that's 121. So that's 180 minus 121 is going to be 59 degrees, right? So we know that this angle here is going to be 59. I just want to go through and always check your mental arithmetic. No sense, yep, 59. No sense in getting a mark wrong on the test just because you didn't bother to check your mental arithmetic. You know, can't be too proud to break out the calculator for subtraction, right? But so I did it in blue because I sort of filled it in after. I just wanted to show that that wasn't what we were given first. But we know now that A over sine A is going to equal B over sine B. And like I said, I always use the same form with the angles on bottom. You're free to use the other one if you want to. It'll work out just the same as long as your algebra is consistent. Right, so now I know that I've got side A, which is going to be 22.5, divided by sine of 59 is going to equal, well, I can pick either of these ones. So let's call this guy X and this guy Y. Why not? Just, who cares? I could call them D and E, I guess. Whatever. Yes, good day, Esther. Thanks for dropping by. Yeah, this is a topic that will be useful for you. Maybe not right away, but definitely soon, because like I mentioned here, this is the topic that Betty Ann's doing in this course, but it's also a topic that comes up in your last unit of your last course. So, don't sweat it too much yet, but you will be doing this topic. And then I'm going to pick. Actually, I'll just go ahead and call this D and E just to show that those are opposite those ones. Don't mind me. The letter is unimportant, right? But this is going to be side D over sine 53, right? Because angle D is 53, so then side D is the one that we can find now. So I'm going to go and I'm going to do my multiplication first, my cross multiply, just to get this sine 53 out of the bottom. And just to show you what's going on, I'm going to go ahead and write out the full shebang. We don't need to do this when you're actually writing it out. Just to show you, right, sine of 53, sine is a function, kind of like an operation, kind of like anything else. But here now, because I didn't get my V8 this morning, look at the my slanted lettering. But it is a decimal. It's a repeating decimal. Like, not repeating. It's a non-repeating sort of infinite decimal sometimes. But still, we can treat it just like a normal number, right? So here now, this sine 53 cancels with this sine 53. And now we're just left with this over here on the side. So what I can do is I can take my calculator. So to prevent myself from rounding as much, what I'm going to do is I'm going to 22.5 times sine of 53. And that's going to give me that number. Then I'm going to divide that by sine of 59. Then I get that, right? So I'm going to end up with 20.96 equals D. Okay? And then for the same, determine the indicated side lengths to the nearest tenth of a unit and the indicated angle to the nearest degree. Right, so that is the one that I was looking for. Yeah, so 20.96 is the answer that they were looking for there. I can, of course, go ahead and find the other side as well. Because I've got it drawn out here and already going, let's go ahead and do that. So I'm going to again do my A over sine A equals B over sine B, like so. Right? I can pick the same ratio for the first one, and it's totally fine. 22.5 over sine of 59. Right? And now I want to find this side E over here. So that's going to be side E over sine of 68. Because again, right? It's the side and then the sine of the angle that is across from that side. Right? So now what I'm going to have is 22.5 times sine of 68 divided by sine of 59 equals side E. And like I did for the last one, you don't use a negative sign? No, not right now we don't. We will. Oh yeah, that's a good point. I will show you one where we use inverse sine next. All right? So now I'm going to go, inverse sine is sort of what we would use if we're finding an angle, not a side. Here I'm finding a side. But in 3b, I'll show you finding an angle. So now what I'm going to do is my 22.5 times my sine 68, right? That's my top part. Then that's going to be divided by sine of 59, because that's my bottom part. And then you have 24.34. 24.34 equals E. And that makes sense, doesn't it? If this side is the largest side, it should be opposite the largest angle, which it is. And this is and this side is opposite the smallest angle, so it should be the smallest side, which it is. So that all sort of makes sense to us there. We can go ahead and do 3b over here, because 3b does use a the inverse sine operation in order to let us find a find an angle. Sort of trailing off. I'm just trying to pay attention to a few things at once here. Although I always trail off in my conversations and words and thoughts and existence, you know. So whatever. It's just par for the course, man. All right, so this is N. This is the symbol theta. What in the world is that? Well, theta, that sort of zero with a line through it, that's a Greek letter. That stands in for an unknown angle. So that just lets us know that it's an angle specifically that we're looking for. I mean, you can use a normal letter or whatever to represent an unknown angle, but it's just kind of convention that the symbol theta is what we use for an unknown angle. Okay? But now, oh, we have this side too, of course. Extremely important. So, as always, I write my formula down first. Right? Another thing we can do over here now is declare variables, so sort of write on the side what we know and what we don't know. That can be really useful here, right? Because, say, side A, or the lowercase a, is going to be, well, this is the one that we've got the pair of, right? So side A is going to be 24.4, and then angle A, or capital A, is going to be 29 degrees, because that's the side opposite that. Then our side B, or lowercase b, is going to be this 45.2. And then angle B is going to be theta, or our unknown angle, right? So this is what we call declare, well, it's more called declare variables in sciences and stuff like that, but it's still a very nice discipline step to take in beginning a math question like this as well. Right, just 1 second there. Okay. So now I'm going to go ahead and I'm going to fill these guys in. So I'm going to have 24.4 over sine of 29 equals 45.2 over sine of theta. Okay? Now, here, like it mentioned on the previous page, it can be, when you're finding an angle, it can be less work to just take this whole thing and flip it, which I'm going to do, right? So I can do sine 29 over 24.4 equals sine unknown angle over 45.2. Totally reasonable to do that. We can take, as long as we flip both sides, we're fine, right? So now I want to get this 45.2 out of the bottom here because I need sine theta by itself, right? Because we can think of, right now, we can think of sine theta as being the variable that we're looking for, right? The inverse sine will only come in at the end. So what I'm going to do now, 45.2 times sine of 29 divided by 24.4 equals sine of theta. So break out my calculator now. You absolutely do not need to look these kind of things up in a table. My goodness. Looking signs and stuff like that up in the table is the kind of work that calculators are made to do for us. Right? And then we divide that by 24.4, and we get 0.8981 equals sine of theta. Now, a few minutes ago, I mentioned that sine is sort of like an operation or a math function, the same as any other math function, right? And what that means is, like anything else, like multiply has the opposite of divide, plus obviously has the opposite of subtract. Sine has the opposite of inverse sine, or negative sine, depending on who you're talking to. But the way we write it out is sine to the negative 1. So if 0.8981 is the sine of theta, then the inverse sine of that number, 0.8981, is going to equal theta. Now, that inverse sine is going to be at a different place on every different calculator, but most of the time, like 99% of the time probably, it's going to be the second function of your sine button. So let me zoom in a touch here. It's a little bit blurry, but you can see it right there, right? So this is the sine button, and you see above the sine button is sine to the negative 1. So for me, I've got to go second function sine, and there it comes up, inverse sine, and I'm going to put in my 0.8981, and I'm just going to click enter. We see about 64, 63.9, right? So I'll call that 63.9 degrees equals theta. Now the back of your book might say 64, I don't know off the top of my head. If you're a tiny bit off on these types of questions, it's probably because of the rounding, because in this step here, I rounded to 4 decimal places. If I didn't round to 4 decimal places, maybe this would have come out exactly 64 instead of 63.9, right? That's not a big deal at all. I would definitely mark it right if you're a little bit off from what the key says. Let's see. Are there some other questions here that I would like to go over? I would like to go over a bit of the, maybe some of the long answer ones here too. So let me go over question 4. What page was this? 139. Yes. Let's do question 4. So question 4 then says, Scott is studying the effects of environmental changes on fish populations in his summer job. As part of his research, he needs to know the distance between 2 points on Lake LaBerge, Yukon. I assume that's French, Lake LaBerge. Maybe it's Laberge. No, there would be an accent if it was Laberge. Scott makes the measurements shown and uses the sine law to determine the lake's length as 36 kilometers. Agatha, Scott's research partner, says that his answer is incorrect. Explain how she know. Well, at a glance, we can tell that Scott is incorrect. Agatha's right about Scott being incorrect, at least, because the Lake LeBerge is opposite of an angle of 74 degrees, right? If it's at opposite of an angle, and that is the biggest angle in the triangle, it's going to be, right? Because let me just do out the triangle here, and then we'll see what we notice when we fill in our angles, right? So we know this angle is 52 degrees, 52 degrees. You know this angle here is 74 degrees. So the angle up top has got to be 180 minus 74 and minus 52, which is going to be 106 minus 52, which is going to be 54. Right? Yes. So this is going to be 54 degrees. Right? And this is our lake over here. Let me draw a little lake. There we go. So my skills of an artist. Employed some chiaroscuro shading. I'll improve on your methods. That's not an improvement. I'll just recite Homestar Runner cartoons to myself while I'm drawing diagrams. That's good. Again, it's great content, right? It's good for people between, internet nerds between the ages of 30 and 35, I guess. Anyway. We know that this angle is 74 degrees, this angle is 52 degrees, and this angle is 54 degrees. Because this is the biggest angle, we know it has to be opposite the biggest side of the triangle. So since this angle over here, this side is 41 kilometers, we know just at a glance that this side has to be longer than 41. Okay? So to determine the distance between the 2 points to the nearest 10th, well, okay, for A then, the lake is opposite the biggest angle, so it must be the biggest side. That tells us what we got to do for A. So then for B, we're going to go ahead now, and we're going to find the length of the side, right? And we're going to use our A over sine A equals B over sine B. And I'm going to go ahead and do my variables over here. So A I'm going to pick to be the side that I know. That's going to be 41.0. Capital A is going to be the angle opposite that, which is going to be 54 degrees, right? And then B, side B, is going to be unknown, so I'll call that X. And then capital B, the angle that I know, is going to be 74 degrees. So now I can go ahead and plug these guys in here and get us an answer. So we're going to have 41.0 over sine of 54. And that's going to equal some unknown side over sine of 74. So what we're going to have is 41.0 times sine 74 divided by sine of 54 is going to equal our side. Now we're going to grab this guy. 41 times sine of 74. I always do it one step at a time like this usually, just to make sure that I don't mess with that. Sort of the order of operations doesn't get messed up or the brackets get messed up or anything like that. That's just a way of making it as safe as possible for me. Divide by sine of 54, hit enter there. We're going to get 48 we'll just call that 48.7. 48.7 equals X. Okay? So determine the distance between the 2 points to the nearest tenth of a kilometer. Hey, look. Yeah, I did it even right. I did it to the nearest tenth of a kilometer even. 48.7 kilometers. And that is the length of that lake. Let's see what the last one. Hmm. I would kind of like to have defined an angle. Uh, oh, okay, okay. Yeah, I guess I'll do number five because number five shows a little bit of a tricksy bit for us here. But I would like to do one more example with a negative sign as well. So maybe I'll bounce back up and do part of C, part of part C, no, part F. I'll do EF afterwards. But for number five here, so an architect designed a house. Needs to give some more instructions on how to do it. One reason I want to do this one is because it brings in a little rule that I haven't mentioned yet today, but when they try to get tricky on you, they're gonna throw in stuff like this for sure. So this is 70 degrees here. This side is 36. Is that 36 inches? Or is that 36 feet? It's 36 feet, right? I don't even don't even know. I don't even know which one's feet, which one's inches. That's 36 feet. Okay. And what else were we told? Well, we're told that the rafters that hold up the roof are equal in length. So whatever length this is the same length. But how can we go ahead and use sine law for this guy, right? Because we've got, say, our lowercase a or side a is going to be 36, right? Capital A, or the angle that relates to A, is going to be 70. But then we've got our side B is going to be x or an unknown. Then the angle B. What the heck is angle B going to be? Right? We're not told. How do we find that? Well, we're told that these two sides are the same length. If the sides are the same length, the angles at the bottom of those sides have to be the same. So we know that this is going to be theta, and this is also going to be theta, the same theta, right? Because the sides are the same, the angles at the bottom are the same because it's an isosceles triangle. So now what we can do is well, basically, we know that this is going to be, they're each going to be half of what's left over, right? So I can do 180 minus 70 is going to give me 110. So then I know that 2 theta is equal to 110 degrees, because these two guys together have to be 110. So I know that theta is going to be 55 degrees. So I know that B is 55. Okay? Now once I have this, simple enough to go ahead and solve. So A over sine A equals B over sine B. 36 over sine 70 equals x over sine 55, or 36 sine 55 over. I do like to write out all my working like this. I mean, it's possible to skip some things, but I don't recommend skipping steps usually in the working. I think writing it all out is worth the extra little bit of effort, especially since you're only going to have to do it, a few times, then you'll be done with the unit. Okay, so now I've got 31.4 equals x. So express your answers to the nearest inch. Well, that's a bit annoying. Anyway, so 31.4 is going to be the answer there for each of these sides. Okay. Like I said, I would like to do one more example where I'm using inverse sine. So I'm going to go ahead and do F over there. Maybe I'll switch over to a different display here. Just because, There we go. So do that one in green. So this is 3F. And this one is kind of like this. All right, and we've got 6.7. We've got alpha, what they're using for that one. We've got theta for that one. We've got 80 for this one. We've got 2.9 over here and lowercase j over here. So 3f. 3f has got a bunch of crap going on. We need to find loads of things. Okay? So I'm going to go ahead and find all of these. So I'll have my a over sine a equals b over sine b. So I'm going to use this as a and b. Of course, well, this is a and a rather. So this is going to be 67 over sine 80 is going to equal, well, I can do 2 point, was it just 2.9? Wow. Oh, 6.7. Okay. 6.7 is 2.9 over sine theta. Because again, I wanted to show another one of doing finding the angle, right? So this is going to be sine 80 over 6.7. I'm just going to skip to this part. 2.9 sine 80 over 6.7 is going to equal sine theta, right? 2.9 times sine 80 divided by 6.7, 0.4263 equals sine theta. Then in my calculator here, I'm going to do second function sine, and I'm going to put in the answer. ANS just populates it with the answer from the last question I do. There we go. 25.2. 25.2 is that angle. Once we found that angle, of course, we can get the other one very easily, because we can do alpha is going to equal 180 minus 80 and minus 25.2, right? So alpha is going to equal, so that's 100 minus 25.2, so that's 74.8 degrees, right? And now I can go ahead and just finish it off by doing one more. I'll just do this one in black so we see that it's a different instance that I'm doing. Well, I'm going to do again my 6.7 over sine 80. Now you don't have to do the same one, but you can, right? And I'm going to do that j over sine 74.8. And they're going to be pretty similar because 80 and 74.8 are close together, so we know that the side lengths are going to be close together as well. But it's going to be 6.7 times sine of 74.8 divided by sine of 80 equals j. And it might look a little intimidating because there's so much algebra being written out here in this like one step, but really, there's not a whole lot to it because the calculator is going to do a lot of the heavy lifting of going and, looking these signs up and all that kind of stuff. Right? So we've got 6.6 equals j, which pans out, doesn't it? It works out. Like I said first, we would expect it to be very similar, but actually a little bit smaller because the angle is a little bit smaller, and hey, it works. Right? So that's a good look at what we're going to do there for sine law. Now I also mentioned on the start of my screen over here on the intro, right? Mentioned that I was going to introduce cosine law as well. So we're 45 minutes in and I've only covered sine law yet, but I am going to do briefly. I'm going to do a bit on cosine law as well. So let me just bring this one up. I won't do as much on cosine law. I maybe will just do an example, and then I'm going to get on to the test review sections. So let me bump on over here. So this is now 2101A Unit 3. Okay, so this one is now cosine law. So look, it says cosine law can be used to determine an unload side length or angle measure in an acute triangle. So basically, cosine law is sort of a rewritten version of the Pythagorean theorem, sort of derives from the Pythagorean theorem. It's basically a version of the Pythagorean theorem that we can use for any triangle, not only right triangles. Right? And the cosine law is generally written as This is how we normally see it written, is the third version here. C squared equals a squared plus b squared minus 2ab cos c. Now the only important thing here is sort of, well, there's a few important things, but the main important thing is that whichever one's the one that's alone over here is the one that you take the cosine of, right? So you can, like it shows here on this page in the textbook, which is quite a good page, it's page 150, put that there along with the notes so you can look it up after. It's a good breakdown of the different forms here, but the important part is that right? So C is sort of the angle that we're going to use, and the rest are sides. A and B are the other two sides of the triangle. So that it looks a lot more complicated than it is. Just like again, right? Like I'm gonna get tired of saying it. You'll get tired of hearing it, but it's true. It doesn't stop being true just because I have to say it a bunch. It does look a lot worse than it is. So let me do questions. Yeah, I'll do questions 2 and 3, and then that should be a good intro to this topic here. All right, so for question 2, determine the side length of x to the nearest centimeter. Okay, so we've got, this is x, this is y, and this is z. 46. It's z, indeed, not z. Unless you're talking about Dragon Ball, then it's z, right? But if it's anything else, it's z. And that's going to be side x over there. Now, the difference between this one and cosine law, right, is that in cosine law, you had to have a pair. You had to have a pair of side and angle. So if we were given this info, like we've got here in question 2, we wouldn't be able to use sine law to solve it, right? Because this 15 is opposite an unknown angle, this 18 is opposite an unknown angle, and this 46 is opposite an unknown side. And since we only have one angle, we don't actually know those angles there. We can't just figure those out, right? If we knew two angles, then we could go ahead and find the third, of course, or use one of the pairs. But here now we don't have a pair, so we can't actually use cosine law. Sorry, can't actually use sine law. We can use cosine law. So now, what I'm going to do is down here, I'm going to write out, like I said, my declaring variables. So I'm going to say that capital C is going to be 46 degrees because that's the side I'm looking for is going to be side C, which is the lowercase c, which is going to be the x or the unknown, right? And then A, lowercase a, is going to be, they can be either one of these, it doesn't matter. But I'm going to call A 15 and B 18. It doesn't matter, A and B are interchangeable here, as long as the C's, the ones that are in the cosine, and the ones that's alone on this side, are the ones that you are looking for. Right? So write out my formula like I like to do. C squared equals A squared plus B squared minus 2AB cos C. Right? It's interesting to know, right, that this is actually just the Pythagorean theorem, kind of. Because, you know, if we take cosine of 90 degrees, what's cosine of 90? Cosine of 90 is 0, right? So if C was a right angle, then this whole term disappears because this part is 0, and we're just left with C squared equals A squared plus B squared. So it's not really a different form of the Pythagorean theorem per se. It is literally the Pythagorean theorem. Just it's thanks to the power, thanks to the magic of trigonometry, we can use the Pythagorean theorem on any triangle, basically, not just right triangles. It's magical, right? Of course it is, obviously. Obviously, there's no, whatever. It's not, math isn't boring or anything. It's magical and mysterious and interesting. And, well, it's definitely mysterious. That part is true. The rest of them maybe not, but mysterious, hey, we got that one. All right, so that's going to be 18, and this is going to be cos 46. And it looks like a whole bunch of writing here, and it kind of is, but now we can just go through and solve those, right? So 15 squared, if I knew that off the top of my head, would be 225, plus 18 squared, which I don't know off the top of my head, which is 324, minus all this over here. Boy. Well, cosine of 46 is that. Then I'm going to times that by 15, times by 18, and times by 2. 375.16, I'll call that. Right? So then x squared is going to be 225 plus 324. Subtract the answer from that last bit. 173.88. Okay, and now we're not quite done, right? Because that's x squared. So now to get x, we of course had to take the square root of 173.88. And in my calculator, I'm going to do square root of the answer. There we go. About 13.2. Determine it to the nearest centimeter. Well, x is going to be about 13.19, so we could say that's about 13 centimeters because they asked us to the nearest cm. So there we go, right? Fairly similar to what we just saw in the sense of like what sort of questions you can solve using this math. It does look a bit more complicated, but like I said, it's literally just the Pythagorean theorem sort of risen from the dead with some other trigonometry bolted onto it, like Frankenstein's monster. Pythagorean theorem, your favorite, Esther. That's right. That's right. Esther is famously known for her unabashed love for the Pythagorean theorem. It's true. She has a reputation far and wide as a person who really enjoys Pythagorean theorem. And the word, too, especially, right? Just the way it flows off the tongue. Pythagorean. Pythagorean. Okay, so let's make this triangle a little bigger. And I'm going to do question 2 here. Or 3. Whatever. Numbers are hard. I don't need to deal with numbers. Not like I teach math or anything. 5.9 meters, 6.2 meters, 2.3 meters, and then one angle which we don't have. We don't have any angle. Oh, okay, good. This one can be a little trickier, but it's just being careful in how we assign our variables, sort of like what we did over here. We're just going to have to be extra careful here about which one we call A, which one we call B, and which one we call C. So the one we're looking for is angle P. So I'm going to, I need to put in my letters on the corners or we're not going to know which one angle P is. Now where are we? So angle P is the one we're looking for, so I'm going to call that guy theta. Guy right there, right? So now the important part is to know which side is A, which is B, and which is C. Remember, side C, or lowercase c, has to be the side opposite the angle that we're looking for. And capital C needs to be the angle. So capital C, there's going to be theta. Lowercase c is going to be 5.9 because it's the one opposite. And then A and B can be either of the other two. 2.3 and B here is going to be 6.2. Right? Now, let me check. Did your other page mention a rearranged version? Oh, it did not. It did not show you a rearranged version to solve for angles right off the start. Okay, so we'll just, that's not hard. You just have to use your algebra skills in order to rearrange it yourself, right? Not super difficult. Well, I can go ahead and write out my c squared equals a squared plus b squared minus 2ab cos c. Now I can go and fill these guys in, right? Then we've got our 5.9 squared equals 2.3 squared plus 6.2 squared minus 2 times 2.3 times 6.2 times cos of c. Boy, that's a lot. It's a lot of stuff put together, isn't it? It's not really that bad. I'm going to before I crunch the numbers here, I'm going to rearrange a little bit of it. I'm going to take this whole section here, right? This whole section, and I'm going to move it to the other side. I'm going to add that to the other side of the equation, and I'm going to move this one over. This one here to the left, this one here to the right. Or scratch that, reverse it. This one to the right, this one to the left. We're going to have 2.3, 6.2 cos c equals 2.3 squared plus 6.2 squared minus 5.9 squared. And then I'm going to call this cos c equals 2.3 squared plus 6.2 squared minus 5.9 squared all over 2 times 2.3 times 6.2. Now, that might look a little bit like gobbledygook right there, right? But not really, not quite, because let me just show you what I've done. I'll just show you over here just in a different color. So it's c squared equals a squared plus b squared minus 2ab cos c. So what I can do is I can move the 2ab cos c term over. This is what I did. 2ab cos c equals a squared plus b squared minus c squared, because I took this c and moved it over, and that moved it over here. Then I'm going to divide by this 2ab. So cosine of c equals a squared plus b squared minus c squared over 2ab. Now, I was surprised that your textbook didn't give you this form to start off with. I believe, why would I move it? I'm moving it just to make it a little bit easier on myself, because c here is what I need to find. And we know that in algebra, when we have to find an unknown, that it eventually needs to be by itself on one side. So I was saying I was a little bit surprised that the textbook didn't show you this rearranged form, because this rearranged form down here is similar to the rearranged bit for the previous one, right? How it showed you a version of the sine law when it flips. But here now, this is a little bit of an easier way. So sort of some of the algebra is done for you. But to carry on over here, what I'm going to do is my 2.3 squared. So cos c is going to equal 5.29 plus 6.2 squared, 38.44 minus 5.9 squared, 34.81 over 2 times 2.3 times 6.2. And I'm just sort of doing out some interstitial stages, I suppose, stages in between that you might not necessarily need to do all the time. So 5.29 plus 38.44 minus 34.81 is going to give us 8.92 on top. Then down below, I'm going to do my 2 times 2.3 times 6.2. That's going to be 28.52. So cos of c is going to equal those two things divided. 8.92 divided by the answer there, 0.3128. So just to show you, similarly to the previous one, right now we've got to do inverse cosine, the same as inverse sine, right? You'll see on pretty much every calculator, at least on mine and on most of the ones I've ever seen, you'll see that inverse cosine is right here, right next to, right just above the cosine button. Well, my camera's a little bit off today, isn't it? I keep going out of the shot when I zoom in, when I lean in. Anyway, so it's going to be inverse cosine of that decimal. So I'm going to go ahead and plug that into my calculator. Inverse cosine of the answer, and we get 71.8. So C is equal to about 71.8 degrees. Now that might look like a lot of steps, right? But the vast majority of what we did there was just rearranging this formula to get this form over here, which is, I know you're probably sick of hearing this one as well, but that's just algebra skills. It's not to belittle it. Algebra skills are a really important part of this math course and of every math course that we do. But what I mean when I say it's just algebra is that that's not really the topic that's being taught here, is how to rearrange this part. They sort of assume that you already have a handle on how to do that rearranging. What they're teaching in this unit, or we're teaching in this unit, is how to fill this formula in to find something like this, right? And the main thing I mentioned up here is that capital C is the angle opposite to side lowercase c. So that since we wanted to find this angle here, we had to make this side the one that was over here by itself, right? The other two, A and B, can move around, but C is important to always be the one opposite the angle that you're looking for. Okay? But I don't want to overload you too much with too many different examples. As you go on in your course, you will notice that perhaps the more common questions are one that just give you a triangle and ask you to figure out which of the two, which sine law or cosine law you're going to use. And the way you'll determine which one to use is basically if you have a pair. If you have a pair of angle and a side opposite that angle, like you do over in these ones, right? Because this one here, say you've got an angle and a side opposite it, that means you can use cosine. Sorry, you can use sine. You can use sine there. 0 cases again today. Wonderful. Wonderful. Good stuff. Okay, to go back over to my intro page, we can see a big lick there from a young little flurry. She was very small. Not very small. She was probably only a few years old in that picture. You can see her one blue eye shining through there. I'm going to do some Unit 3 test review for 3102A. So Esther, good thing you're there because I'm going to do a few questions for the test that I believe you're signed up to do tomorrow. So let's go back over here to the document display. Peter, clear as mud. Yeah, I mean, don't worry about it being a bit muddy right from the start, because yeah, it is quite a lot of algebra all at once for those that topic, and I will be happy to do more examples as you get into the other questions on that. It's a really big topic, and it's done in both programs and done quite a bit. So it's definitely something I would like to spend some time talking about, so I can, so that yourself and anyone else who's working on it can see the videos that I'm saving as well. This is now going to be Math 3102A Unit 3 review. Unit 3 review here. Okay. So this is in your textbook. This is page 162. I'm just going to go down through and do a few of these questions. So Marissa's pay varies directly with the number of hours she works. She earned $72 for a 6-hour shift, which equation models the relationship between Marissa's earnings and the number of hours she worked. Well, she got $72 for a 6-hour shift. Well, what was her rate of pay? What was her pay per hour? Well, that's not hard, right? So it's going to be 72 divided by 6 is going to be $12 per hour, right? So $72 per 6 hours is $12 an hour. It's not hard to figure out. So then we know that the answer is going to be E, or C, sorry. I said E because there was an, excuse me, because there was an E there by it. E is going to be equal to 12H, right? 12 times the number of hours. For the next one, for 2, which equation represents a non-linear relationship? That one's actually not a great question for this unit. Actually, you don't need to know that one, really, but it's B. B is the answer. B is the answer because the R is squared. Yeah, this is an aside. You don't really need to know this one. R squared, if the variable is squared, then it becomes a curved line. It becomes a quadratic. I think you see a bit on quadratics in one of the courses coming up. A quadratic looks like a U or an N, depending on if it's a positive or a negative quadratic. But anyway, that one's not super duper important right this minute. Taxi charges an initial $3.50 plus $1 per kilometer. Sounds like a cheap taxi. Or expensive? I don't know. Honestly, don't know. What is the cost of a 10-kilometer ride? Well, we know that the cost then is going to be 1 times the kilometers plus 350, right? So this is our slope or the rate of change. Rate of change is the same as the slope. And then our initial amount is 350. So what's the cost of a 10-kilometer ride? Well, the cost is going to be 1 times 10 plus 350. So the cost is going to be 1350. That's not hard. So that's going to be option B. Okay, these ones are maybe a bit easier than some of the ones that you'll have to do. But here now, question 4. Question 4 is a good one. Which table of values represents a direct variation relationship? Right? Explain how do you know? Well, first up, like you did on the most recent assignment, you do have to find out if these ones are have a constant rate of change or not. Now here, I believe all of these, yeah, these ones are not as tricky. Actually, the ones in the assignment and review sheet were a lot trickier than what the book is giving. Hey, here these ones all have constant rate of change. Right, so if you look at let me move over so my cursor is there. Here we can see that the y is increased by 1 and the x is increased by 1, so that's fine. Here the x is increased by 1 and the y is increased by 2 each time. Here there's 1 on the x's and 1 on the y, 2 on the y, 4 on the y, 8 on the y, 16 on the y. Okay, all right. So I'm actually going to write these ones out. So A is, yeah, let me write it down. Let me write it all down. It's going to take a minute or two longer, but I'm going to do it this way so that we have you have a better resource here from these notes when you go to review it for studying, say for example. So it'll only take a few seconds longer, but I'm going to do out these lists of values here. And then we can talk a little bit about what they represent. Right? X and Y, X and Y, X and Y. Okay, so we've got the first one, 0, 1, 2, 3, 4, and 5. Then 1, 2, 3, 4, 5, and 6. Easy peasy. We have 0, 1, 2, 3, 4, 5 for all the x's, don't we? Yeah. Just going to go through them a bit quick here. 0, 2, 4, 6, 8, 10. 1, 2, 4, 8, 16, and 32. 0, 200, 250, 350, 400. Oh no, these are better questions than I thought they were when I looked at them first. Okay. So these are the sets that we have, right? And now if we look at this one, we see there's two things that we're looking for, right? So this one has a constant Okay, so this first one, we know this is partial variation, right? Because there's a constant rate of change, constant difference, and then when x equals 0, y does not equal 0, so it's partial, right? This next one, Okay, so this one here then, it's got a constant rate of change because this goes up by 2, then this is by 2, then this is by 2, then this is by 2, and this is by 2. And the x's are going up constantly as well. So this is a constant rate of change. When x equals 0, y equals 0. We can see that over here. Therefore, it's direct. This one, okay. And this one has no constant rate of change because it goes from 0 to 200. So it goes up by 200 there for this first one. Then it goes up by 50. Then it goes up by 100. Then it goes up by 50. Then it goes up by 100. And even if we see a pattern, right? Like this one here, we're starting to see a pattern, but because of this first one, there's not even really a pattern at all. But say in C here, in C there's a very clear pattern, isn't there? So it starts off at 1, then it doubles to 2, then it doubles to 4, then that one doubles to 8, and that one doubles to 16, and that one doubles to 32. Right? Even though we can see that it's doubling each time, and therefore there's a pattern, it still doesn't have a constant rate of change. Right? So then this one is neither direct nor partial, and this one is neither direct nor partial as well. Okay? Then for question 5, let's do question 5. I'll switch over to a different color just so we can see it over here. I'll do question 5 up here. Which graphs represent direct, and how do I know? Well, that's a good one, right? We do need to mention how we know for these. So I know that well, they both are straight lines. Now that is important. It is important that these ones, like B and D, they're both straight lines, right? Because if they're a curved line, like in C, then they don't have a constant rate of change, right? Any line with a constant rate of change is going to be perfectly straight, unless it's vertical, and then it's just wacky once it's vertical. Um, you need to mention that both have y-intercept equal to 0, so they're a direct variation. And then for B, yeah, I'll just keep doing it in blue so we can see it's the same. So I know now that A has partial. It's linear. It's linear, so it has a constant rate of change. But the y-intercept does not equal 0, so partial variation. Okay. So Esther, you can let me know if you have any specific topics that you would like me to cover, say for review for your test. I just wanted to cover a few of those briefly there. I think that is it's a quick overview of some of the different topics that you had to do. And you did really well on your review sheet, I do recall. So I think that you're probably well prepared to write that one tomorrow. If you have anything else that you would like me to go over today to show you, you can mention that in chat, or yeah, in chat is the easiest way to do it, and I will get to that one. Like say it's another question from a book, or one from the assignment, or anything like that, or the review sheet. I am going to do a very brief part on Math 2020 as well. Not going to spend a ton of time on that one, but I am going to do a brief review on that one here now. So while I'm doing that, if you have any other questions to ask me, you can say go look it up or whatever, send it to me in chat, and then I can get to that before the stream ends. But now I'm going to go on to Math 2020 Unit 1 review. Back on over to my intro screen, just so I have a little like bookmark place in the video for after I save this. I have been saving these and getting them uploaded to YouTube and stuff, but the quality when I upload it to YouTube is just not there, man. Twitch gives me a lot better quality, so I'm currently pretty happy keeping the videos as VODs on Twitch. I as long as I can as long as I can figure out how to not get them deleted after 60 days, as long as they can stay up there forever, I'll more than happy to use Twitch as the video distribution. Anyway, time to pop back over here. Here we go. So this is the Math 2020 page that I was looking for. So I'm just going to go down for real quick and do some of these questions. These are not super difficult, but this is just as a very quick review. And this is page 156 in Prism Math Purple. It's one of the non-required pages. Right? So for 1A, well, we know that the perimeter of any two-dimensional shape is just the distance around the outside. So here we've got 9 and 4 listed over here. You say Prism Math? Yes. Yes, I did. The book is called Prism with an M. Like a rectangular prism or a triangular prism. I guess there could be a rectangular prism, though, I suppose, or like a cylindrical prism. Yeah, we're getting very Foucault here, aren't we? A panopticon, cylindrical prism with the guards in the center in an enclosed cylinder that you don't know where they are or where they're watching, and all the gates are open, man. All the doors are open, so prisoners can come and go as they want, but they can't because there could always be someone watching them. Right? We're getting postmodern up in here all of a sudden. Okay, go back over to my prison math. So for one, the perimeter. I mean, all we've got to do is account for the fact that there's a 9 on the left that we don't see, right? Because this is a 9. Oh, my cursor's not showing up. Because this is a 9 over here, we know this is a 9. Because this is a 4, we know this is a 4. So our perimeter is just 9 plus 9 plus 4 plus 4, right? 18 plus 8, 26 centimeters. Area. Well, area is going to be length times width, right? So it's just going to be 9 times 4. Non-Euclidean prisms. That's good. That's good. I like that. Yeah, panopticon is an example of a non-Euclidean prism. Boy, there we go. Yeah, take that postmodernism. We're gonna throw math terms in there. You won't know what anything means. These are jokes mostly for me. They're not even really jokes per se. Length times width, 9 times 4. I'm just going to write that in there, 9 times 4. So 36 centimeters squared. Right? Pretty straightforward stuff. 1B. Well, the perimeter of a triangle, again, it's always the distance around the outside, right? So for the perimeter, or the distance around the outside, we obviously don't need to be concerned with this 6, which is the height. We just need to be concerned with the ones around the outside. So that is, of course, going to be 7 plus 8 plus 9, which is 15 plus 9, which is 24 centimeters. Area of a triangle. Now, you will be given these on a test, but you do have to memorize these. You might not have to memorize them right now, but you're definitely going to have to memorize this for the future. So the area here is going to be a half times the base, which is going to be the bottom, or 9, times the height, which is 5. Now, technically, the base needn't be the bottom. It's just the base and the height need to be perpendicular, right? Need to be offset at 90 degrees from each other. So now we're going to have the area. 9 times 5 is 45. Half of 45 is going to be 22 and a half centimeters squared. Right? And then part C. C is a parallelogram. Again, the perimeter is just the distance around the outside. So even though it's slanty looking, doesn't mean Doesn't mean anything about the perimeter. Doesn't mean jack crap. I don't know why I said jack crap instead of jack squat, I could have said, which wouldn't have even flirted with saying the word shit. Oh no! Oh gasp. My stream, my precious G rating. So that's going to be 36 centimeters. Maybe because I haven't been playing like Warsan Gulch on stream, I haven't actually really I haven't even really made a joke of the cursing part, right? At any point. I haven't been encouraged or forced into a tirade by, you know, having entangling roots being resisted on the flag carrier or something, right? Like this is real shit. So the area of one of these, right, of a parallelogram like this, it's actually just going to be the base times the height, right? Now, this is one you don't necessarily need to memorize, but it's not going to be 13 times 5 because 5 is the slanty bit. It's going to be 13 times 4 because 4 is the height. So 13 times 4, so that's going to be 52 meters squared. Okay? Pretty straightforward stuff. Complete the table below is 3.14 for pi. Okay, great. So diameter, radius, circumference. Boy, I didn't give myself enough space, did I? And area. Okay. Did not give enough space here for these guys. But I'm going to go ahead and draw myself out a rudimentary quick table here. So then for question 2, it's going to be 12 centimeters in diameter. If we know it's 12 centimeters in diameter, we have to know the radius is half that, right? Circumference, well, we know that circumference equals pi times diameter or 2 pi times the radius, either way. So this one is going to be 12 pi's, which is going to be exactly 36. Because pi is exactly 3 is the joke. That's the Simpsons joke, right? I've even got a Simpsons reference in my title. I gotta make Simpsons jokes. And like, pi is exactly 3. That's basically the perfect reference for my stream. Simpsons and, math and dorkiness. There you go, right? That's pretty much my wheelhouse, at least for this stream. 37.68 centimeters. And this one is centimeters, not centimeters squared. Area, though, we know that area is equal to pi times radius squared. So here the area is going to equal pi times 6 squared, which is going to be 36 pi, which is going to be exactly 108. What? 113.04. That's not right, but it is. 113.04 centimeters squared. I gotta stop doing that pi is exactly 3 joke, or I guarantee you, I'm gonna have students being like, but sir, you told me the pi was 3. I put it in a question. I don't know why you sound kind of like Kermit the Frog mashed up with Grover. But this is my voice. Oh, Miss Piggy. No, it's not good. It's not good at all. For question 3, the radius is 3 millimeters, so the diameter is going to be 6 millimeters. Circumference, all right, so the circumference for this one, again, pi times diameter. Circumference is equal to 6 pi, so the circumference is equal to, like I say, normally I'm not about this 3.14 life. I like to use my pi button on the calculator, but I'm going to use 3.14 for this course because, you can see it right on the page. It's what we're told to use. 18.84 millimeters. And the area is going to be pi times radius squared. The area is going to be pi times 3 squared, or 9 pi, which is going to be 28.26. Oh, it's millimeters. Millimeters squared. Now, generally, I won't I will correct it if you don't put in the squares here for these. You would probably lose, like, if it was worth 2 marks to find the area, I mean, you might lose half a mark if you forget to put in the square there for the units, because the units are important, right? So, you know, try to make sure to get those, because it's easy marks to get, but easy marks to lose. It's important to know that area is always going to be squared units, right? Because the area is something squared. So now for 4. 4 is to find the surface area. Now you are going to be given a sheet that mentions the surface area of all the shapes, right? But you are going to have to remember kind of how to find them based on the formula that you're given. So the surface area of a rectangle is going to be 2 length width plus 2 length height plus 2 width height. And the important thing is that we have each combo, an L and a W, an L and an H, and a W and an H. We have to have each of those combos there, or he's not going to work out. Okay? And now for this one, I'm going to say my length. I'm going to look at my question there, and I'm going to set my length is equal to 3 cm. My width is going to be equal to 6 cm, and my H, or my height, is going to equal 1 centimeter. Now I'm going to go through and I'm going to fill all those in. 2, 3, 6 plus 2, 3, 1 plus 2, 6, 1. 36 plus 6 plus 12. That's going to be 54 centimeters squared. That's all we got to do for one like that, right? I'm gonna keep going down here. Gonna do a few more off of this sheet, but again, I want to move through these fairly quickly. This is going to be 4b down here. We know the surface area of a cylinder. Again, you're given this one. That's going to be 2 pi r squared plus 2 pi r h, right? We need to know this is top and bottom. We talked about this one before, and this is sides. Okay? So now we're going to need to go through and fill out what we know. We know that our radius from our question, our radius is 3 meters. Our height is 9 meters. Now we can just go through and fill those guys in. So we've got the surface area is equal to 2 pi 3 squared plus 2 pi 3 and 9. Right? So that's going to be 18 pi plus 27 times 2 is 54. 54 pi. Right? So I'm going to have surface area equals, oh, I'm starting to slide off the sheet here. It's going to equal 72 pi. So then surface area is going to be, I'm just going to plug that in here, 72 times 3.14, 226.08. 26.08 meters squared. It's always going to be squared for those guys. Right? Okay. So again, like I said, Brittany, I'm going to go through these ones pretty fast because you have seen all of these before. And this is just a review, right, of something that you did quite a while back. But I thought where it was done so far back that it would be useful to have a bit of recap of what's going on here, right? So again, this is page 156, excuse me, page 156 in your notes. Now here, for 4C, we have a triangular prism, right? But for all of these now, all we really need is, well, we're just adding up all 5 of the faces, right? So that's how surface area works for all these shapes. You're not necessarily going to get a proper sort of easy to handle formula all the time for these guys, but it's not super difficult, right? Because say we've got I'm going to call those sides A, B, and C, like you would um, off of Pythagorean theorem, right? So we're going to say the surface area here is going to be A times H plus um, B times H plus C times H, right? Plus here it's going to be uh, plus, we're going to call that A times B, right? Now you're not necessarily going to see it written out this way, but why in the world, why has Peter done this? What have we actually got there? So let me show this one with, I think I should probably do it out as a diagram here, show you what in the world is going on. Right? And we're told here from this one that this is a right triangle on the top and on the bottom. We were indicated that those are both right angles, right? And we're told this is 10 centimeters here. We're told this is 8 centimeters that way. It's going to be 6 cm high, and it's going to be 14 cm this way, right? So we can see right from the start that we've got 5 different faces, don't we? So why do I only have 4 things here? Well, we'll get to that in a second. But we know this front one here, right? So if I, how about I write this out over here in a different color? So 10, I'm going to say that's going to equal, I'm going to call that side A. 8, I'm going to call side B. 14, I'm going to call side C. And then 6 is going to be H, or the height. Now I used A, B, and C because this is a right triangle, right? And if we have a right triangle, like in the Pythagorean theorem, the two sides that are next to the right angle are A and B. The side that's opposite the right angle, or the hypotenuse, that one is C. But the most important thing here is to realize that, say this face, this front face here, like this one, that one's going to be it's going to be A across the bottom and H high. So this one's going to be side AH over here, right? Or A times H. Then if we were to look at, say, this one over here, which I'll do in green, like that, we know that that one is going to be B times H, right? Is going to be that side there. And say if we had this side that's sort of in behind, that we can't quite, sort of in back behind is that side that goes across there. That one's going to be 14 times 6, which is going to be C times H. So that's the side back here, right? So I'll say AH is this front one, this one that's here in blue. Color that one in again a little bit more, a bit darker, right? So those are the 3 sides, the 3 lateral sides, basically, to this prism. Then we also have the top and the bottom, right? So I'll do that one in black there. Might be getting a little bit busy here now, but this is just showing you how we have the top and the bottom, right? So the area of the top, we know it's a triangle, right? So a triangle is going to be half of the base times the height. And here now, the base can be 10, the height can be 8. So it's going to be a half of A times B. But we also have the area of the bottom, which is going to be a half AB, right? And we also have, like I said, the area of the 3 sides. Area of all the 3 sides is going to be, like we just went through and saw, it's going to be AH, so the front, this side, plus BH, which is this side, plus CH, which is that side over there, right? So then the full area is going to be this plus this plus this. So the area of the full shape is going to be AH plus BH plus CH plus a half AB plus another half AB. So it's going to be area of the full shape is going to be AH plus BH plus CH plus AB, because there's 2 of those, right? So this is just a little aside over here for this question. to show how we got there. Now, I'm not saying that this question is not, it's not a super difficult question. I just want to be really painstaking and point out where all these different sides are coming from. All right, but now to solve it, I'm just going to go ahead and plug in these values that I wrote down in blue over here. So this is going to be 10 times 6. This is going to be 8 times 6. This is going to be 14, not 16, 14 times 6. And this AB is going to be 10 times 8. Okay, I didn't really leave myself enough room. So then the surface area is going to be 60 plus 48 plus 84 plus 80, right? 108, 194, 108, right? 192, 272. But again, don't trust adding stuff together in your head like that, right? Just want to model good behaviors and also, have a cop out for in case I was wrong. Model good behaviors and even take the painstaking little, addition ones like that and plug them in the calculator. But 272 centimeters squared. Okay? That is deceptively 4C is a bit conceptually maybe one of the trickier ones on this page, but again, it's all math that you have seen, and it's all just straightforward, finding area of rectangles and triangles and just making sure that you're accounting for all the sides of the three-dimensional shape. Then for question 5A, let's go ahead and do that one. So find the volume of each figure. Now volume is easy. Volume of a rectangular prism is just the three measures multiplied together, LWH, right? So here we know that volume is just going to be 13 times 6 times 7. I don't know what 42 times 13 is off the top of my head. 546. And now here, you need the centimeters cubed, right? It's important to remember that one's going to be cm cubed. Now the volume of a, so for 5B, actually, let me go bring it up so I can show it to you exactly what it's going to look like when you do it on the test. Actually, let me go get that. So we do have a formula sheet here for you. And I can't remember, actually. I should have found this before the stream. I can't remember what folder I put that formula sheet in. Okay. Now I don't have an example there to bring up on screen of the formula sheet for this test, unfortunately. The volume of a cylinder of any regular shape is just the area of the end of the shape multiplied by the height of the shape, right? So here, when you look up this one, you'll see the volume is going to be pi r squared h. Pi r squared is just the area of the end, right? And then h is the height. So we know now that the r here is going to be, what is that, 2? Yep, 2 meters. The height is 5 meters, so we're just going to go through and plug it out. 2 squared times 5. Volume is equal to 4 times 5, which is 20 pi. So the volume is 20 times 3.14, which I'll use because it's this course and that's what it's asking us to do. It's going to be 62.8, and that's going to be meters cubed, right? And then for C, we're going to be on to the volume of a right square pyramid. So the volume of a right square pyramid is going to be a third of the base times the height is how you'll see it written out sometimes. But the base here is not just one measurement. The base is going to be the length times the width of the base. So a third LWH is sort of the best way of writing it down. And that allows for there to be different measures in both, and not just the same. You know what I mean? not just the same length times width for the base. So then the volume here then is going to be, let's see, 1 over 3 times length is going to be 10, width is also 10, and the height is 15. So that's 1 over 3 times 1500. So it's going to be 1500 over 3, which is going to be 500 millimeters cubed. Right? And that's all. Oh, yeah, how's it going? Nice layer, Darth. Yeah, thanks for dropping in. You're catching me right at just at the end, actually. This was that was the last question I wanted to get to today. But yeah, thanks for popping in. Yeah, I don't know I don't know if you had any questions for me, but yeah, today is this whole week has been pretty crazy for how busy it is. I've got 5 tests to administer tomorrow, which is it's a fair bit of work for me to get ready. Um, but yeah, I've been but it's good. It's good to still be busy during social distancing, right? It's better than the alternative. And lumber with a lot of work today. Yeah, yeah, me too. But it's great. It's great for me to see that because if I'm working a lot, that means that the students are engaging and they're doing a lot of work, right? So it's always really good to see that people are taking advantage of the resources that we're creating. We being myself and the other instructors. We're not all doing the same things, of course, but we're all doing something in order to provide support and more resources for students. So I think that it's always great to see people being prepared and taking the initiative to use this unprecedented distancing time to help keep improving your education and to keep working. Can't go a day without learning something new. Well, that's great. Yeah, that's a great attitude to have in life for sure. That is the whole purpose of life. Absolutely, it is. Yeah, it really is. Like, yeah, for me personally, like, I don't know, I do like learning new stuff in academics. Um, Also, just learning more skills, right? Like, I mean, I'm learning more and more about about video editing and about streaming, producing as I'm going. Learning more. I'm always trying some new cooking recipes. Yeah, that's a fun one. It's a fun one to learn for sure. Absolutely. Yeah. Knowledge is indeed its own reward. Oh, if you like to teach yourself stuff, let me tell you. MIT has a lot of their coursework sort of supplies that are online for their courses. I mean, it's obviously, some of it is difficult to approach because of um, how involved and how detailed the courses are. Because I mean, it's friggin' MIT, right? Like, it's one of the. I mean, that's where Gordon Freeman graduated from. If he was a real person and not just a figment of Gabe Newell's imagination. Um, but I mean, they've got a lot of their course materials that are online, which is a fantastic resource for people that are just looking to learn new things. Right? But thanks for stopping by. I do regret having to go so quickly because I got a fair bit of stuff to get to before my day is over. Right? But yeah, thanks for stopping by. Hope to see you again tomorrow. Yeah, and I hope someone watching. I'm sure my students that were watching earlier benefited from the stream most certainly. Check out the MIT recommendation though. Yeah, yeah, it's a good whatever subjects you're into, right? Um, whatever subjects you want to learn, they've got stuff on there about it for sure, and it's all publicly available, which is wonderful. I mean, you don't get the piece of paper saying that you finished a course at MIT, but you do get some of the learning, right? Which is, I guess, that's just as important. That's more important, of course. Of course, it's more important. All right. Thanks for being there. Stay safe, and I'll see you again tomorrow.